autopilot. Everything is on autopilot. So sometimes you're going to choose W incorrectly and then have to do it again and choose something else. When you're searching for a W, what are you looking for? When you're searching for a W, and this is in your notes, everybody, you have the answers. If you're searching for a W, what are you looking for? You're looking for two things that what?
Are the derivative.
One is the derivative of the other. Yes, right, Morgan. Exactly, exactly. So when you're looking, for example, in number 1, what are those two things on number 1? You have x squared. What's the derivative of x squared? 2x. So it's not quite the same thing, but it's almost. And then up here you have 4x and then 4, so then that 1/4 ends up there. It's the same thing all around. You look for pairings like that. You look up for pairings like that. So of the one for 8 says let u equal 2 plus t. So what does d, so it's going to be du dt is going to be 1. So you try this, and does it work? It doesn't work. It doesn't work. So if you try w substitution, this does not work. This does not work. But what can you always do to this if you really had to? What could you do? Like, what happens in here? You can what? What? Boy, you can multiply it out. If you multiply it out, it just turns into a, what is this? This is a polynomial. Do you know how to integrate every polynomial? Yeah, you can just straight out integrate each polynomial. So don't forget that you can expand. You can expand. That's one of the challenges when you're integrating is you're going to get a new method, w substitution. Is w substitution going to work in every case? No, it's not. So sometimes you can just simplify / expand and you're all set. Does that make sense? Got it. Any other cool? Yeah, so you let u equals t squared, so du is 2 dt, and then you end up with 1/2 du is equal to t dt. So where does this go right here? This ends up going right there. And then instead of t squared, where does that go? That's going to turn into u. In this case, this answer he uses u substitution. Remember how I said some books use u and some books use w? Does the math change at all? No, it doesn't. So you end up with this right here. You end up with sine u t dt. What do we think w should be on A? What do we think w should be on A? What do we think w should be? Take a guess.
X squared minus 4.
Yeah, that's a great thing to try. What about B here? What do we think w should be here? What do we think it should be? Take a guess. Yeah, 2x minus 8. Things underneath radical signs are great targets to try. They're great targets to try. So these two right here. How about you get to the board with somebody else right now and see. So on this one right here, we gave the w, so dw dx is 2, so dx is dw over 2. When you do the substitution, the best thing you can do is simplify first and just be really careful about it. So the 4 over 2 comes from the 4 and the 2 right there, and then you integrate, and you end up with 4 times 2x minus 8 to the 1/2 plus c. So just to reiterate, the thing you're going to have to remember how to integrate is this. You have 4 over 2 integral of w to the negative 1/2 dw. That's the whole thing you have to integrate right there. So that's 2w to the negative 1/2 dw. So it's w, what's 1 greater than negative 1/2? Not a rhetorical question. What is 1 greater than negative 1/2? 1/2. So you plug that over 1/2, the 2 is still there, and it's plus c. So what's 2 divided by 1/2?
4.
So you have 4w to the 1/2 plus c. You only substitute at the end. So it's 4 times, and something's a little different here, 2x minus 8 to the 1/2 plus c. The group over here had a negative sign. You guys went down.
Yeah.
You're like, don't look at it.
Yeah,
Okay. You got it? Okay, you went down. Okay, so on this one right here, let's look at C and D now. Let's look at C and D. For part C here, and its derivative, do you see a function and its derivative? Yeah, so what do you think W is going to be on this one? A function and its derivative. What thing's derivative is there? Sine, yep. Sine of x. Keep in mind that sine to the 5th x is sine x all to the 5th power. Okay, so get back to the board with your same groups, everybody. If you were just writing, change groups, everybody. If you were through the radical sign, right? So in this case, we had w equals x cubed plus 2. So dw dx is equal to 3x squared. So dw is equal to 3x squared dx x, so dx is equal to dw over 3x squared. When you make the substitution, you end up with 3x squared over the square root of w times dw over 3x squared. And is that the best kind of cancellation you can get on these?
Yes.
Yeah, it doesn't get any better than that, where it gets rid of everything, effectively. So you end up with the integral of 1 over the square root of w dw, which is w to the negative 1/2 dw. What's the integral of that going to be? 2w to the 1/2 plus what? Plus c. So you end up with 2 times, what was w? X cubed plus 2 to the 1/2 plus c. And this is where you stop. You also could write it if you wanted to. You could write it like this if you wanted to. That's fine. I'd rather, either one is fine. Either one is totally fine. Either one is totally